Hey everyone, and welcome to today's Explainer. I am incredibly excited to guide you through this material today because we're taking a journey into your body's absolute, ultimate, multi-layered shield, the integumentary system. You know, it's so much more than just a biological wrapper that holds you together. This is a highly dynamic, living suit of armor.
Here's the roadmap for our outside-in journey today. We're going to start by meeting your body's armor, explore the layers of the epidermis, dive down into the dermis and hypodermis, check out the hair, nails, and glands, and finally, look at healing and skin cancer.
All right, Section 1. Meet your body's armor. So what does the integumentary system actually contain beyond, well, just the skin itself?
Let's dive right into this cross-section. The very first thing you'll probably notice is just the sheer density of this system. It is completely packed. Now, your skin actually consists of only two true layers. You've got the outer epidermis sitting at the very top and the deeper, much thicker dermis right below it. Beneath that, you'll see the yellow, fatty hypodermis. Now, that's not technically a true skin layer, but it serves as this vital foundational padding underneath. And as you can see, this whole system includes all these accessory structures: hair shafts, oil glands, sweat glands, nerve endings, literally embedded right here in the armor.
So why does all this matter? Well, because this system does far more than just cover our internal organs. It is basically a biological multi-tool. Sure, it provides protection and waterproofing, but it also acts as a crucial thermostat for regulating your temperature. It's this massive sensory array that lets you feel the world, an active immune defense, and it even acts as a solar-powered factory for vitamin D production. A really great way to remember the basics is just this: your skin protects you, helps you feel, helps you sweat, and helps make vitamin D.
Moving right along to Section 2, layers of the epidermis.
The epidermis is made of keratinized stratified squamous epithelium, and it essentially relies on four main cell types. We can easily remember them using this incredible KMDT mnemonic. K is for keratinocytes. They make keratin, which is the fibrous protein giving your skin its strength and waterproofing. M is for melanocytes. These produce melanin, which gives us our skin color and, crucially, protects our cells from UV radiation. D stands for dendritic or Langerhans cells, which act as our vital defense cells. And finally, T is for tactile or Merkel cells, which are our touch cells. KMDT. It perfectly organizes the builders and defenders of our outer barrier.
Now, you might be wondering, how are those cells actually organized? Well, to remember the structural layers of the epidermis from deep to superficial, just keep this catchy memory phrase in mind: best skin gets love and care. Let's see how this actually builds out. So, best skin gets love and care translates to the 5 strata or layers of the epidermis. Think of this as the little micro journey of a single skin cell. It starts way deep down at the stratum basale. This is the highly mitotic layer where the baby cells are literally born. As they get pushed up, they enter the stratum spinosum, named for its spiny appearance because of these super strong desmosome connections. Next is the stratum granulosum, where the cells produce lamellar granules to form a waterproof barrier. Then they pass through the stratum lucidum, which is kind of a clear layer. Finally, the cells reach the stratum corneum, and by this point, the cells are completely dead, fully keratinized, and serve as that tough outer protective layer that takes the daily wear and tear.
Now here's a quick caveat. Not all skin is exactly identical. You have thick skin, like on the palms of your hands and the soles of your feet, and thin skin everywhere else. The main difference? That clear stratum lucidum layer we just mentioned is only found in thick skin. Thin skin simply lacks that extra layer of padding.
While we're still looking at the epidermis, let's talk about color. Normal skin color is actually formed by a blend of 3 pigments, which we can remember as HMC, how my color forms. H is for hemoglobin, giving a red or pink hue from the blood. M is for melanin, the brown or dark pigment providing UV protection. And C is for keratin, a yellow or orange pigment. And here's a pretty fascinating fact. People don't actually have different numbers of melanocytes based on skin color. We all have roughly the exact same number. Darker skin simply means those melanocytes are producing more melanin pigment.
All right, Section 3, the dermis and hypodermis. Let's dig a little deeper.
Before we dissect the dermis, we really need to make a critical distinction between the layer we just left and the one we're entering. The epidermis up top is avascular. That means it has absolutely no blood vessels. If you've ever had a paper cut that stung but didn't bleed, it's because you only sliced the epidermis. The dermis below, however, is highly vascular. It is incredibly rich with blood vessels. So an easy memory trick: epidermis equals no blood. Dermis equals has blood.
The dermis itself is made of connective tissue and has this absolutely incredible architecture, divided into two distinct parts. First, you've got the papillary layer. This contains dermal papillae that form the friction ridges which literally create your unique fingerprints. Below that is the reticular layer, the thickest part of the dermis, packed with collagen fibers for massive strength and elastic fibers so your skin can easily stretch and recoil. Because of how these fibers naturally arrange themselves, we get what are called lines of cleavage, the specific direction these skin fibers run. And understanding these cleavage lines is actually a huge deal for surgeons. Making incisions parallel to these lines minimizes scarring and promotes vastly better healing.
And this brilliantly illustrates the dynamic nature of the dermis. Remember those blood vessels we talked about? They basically act as your body's thermostat. When you're hot, your blood vessels experience vasodilation. They get wider, bringing a lot more blood up to the skin surface to release heat and cool you down. Dilation equals more blood equals cool down. But when you're cold, they undergo vasoconstriction. The vessels get smaller, keeping blood away from the skin to retain your core body heat. Constriction equals less blood equals keep heat.
Next up, Section 4, Hair, Nails, and Glands.
Let's start with hair. Hair grows from a matrix deep inside the hair bulb and receives its nutrients from a blood-rich dermal papilla. But it doesn't just grow endlessly at the exact same rate. It follows the highly structured, three-stage dynamic life cycle that you can easily remember with the acronym ACT. First is anagen, the active growth phase where the hair is actively lengthening. Next is catagen, a transition phase where the hair follicle actually shrinks. And finally, telogen, the resting phase before the whole cycle eventually starts over. Anagen grows, catagen changes, telogen rests.
Now, let's look at the exocrine glands. These are made of epidermal tissue but dive way deep down to sit in the dermis. You have sudoriferous glands, which are your sweat glands, and these come in two main types. Eccrine glands produce watery, salty sweat and open directly onto the skin to cool your body down. Epicrine sweat glands, on the other hand, secrete a thicker substance that bacteria love to feed on, which is what actually contributes to body odor. Then you have sebaceous glands. Just think sebaceous equals sebum equals skin oil. They produce the oily sebum that keeps your hair and skin from drying out. We even have modified glands, like ceruminous glands in the ear canal that make earwax, and mammary glands that make milk. It is just an incredibly versatile system.
Finally, Section 5, Healing and Skin Cancer. So what happens when this armor takes a hit and gets breached by a wound? It undergoes a structured four-step biological regeneration process. Step 1. Clot. Blood flows to the area and clots to form a scab, essentially sealing the breach. Step 2. Clean. Immune cells rush right in to clean the wound of debris and any bacteria. Step 3. Build. Fibroblasts begin rebuilding the connective tissue while epithelial cells multiply to cover the wound surface. And Step 4. Scar. Finally, the tissue remodels itself, often forming a stronger but slightly less flexible scar tissue just to ensure the armor holds intact.
But sometimes the damage isn't a physical cut. It's cellular mutation, often from the UV radiation we discussed earlier. There are three major types of skin cancer, categorized by the BSM acronym. B is for basal cell carcinoma, which often presents as kind of a pearly bump. S is for squamous cell carcinoma, which typically looks scaly or flaky. And M is for melanoma, which is by far the most deadly form.
So why exactly is melanoma the most deadly of the three? It's the most dangerous form of skin cancer because of its profound ability to metastasize. This means the cancer cells don't just stay in the skin. They can actually enter those blood vessels we talked about down in the dermis and quickly spread to other vital parts of your body. Because it targets the melanocytes, which are the very cells trying to protect us with melanin in the first place, it really highlights how absolutely critical early detection and UV protection are.
Well, we've traveled from the dead protective flakes of the stratum corneum all the way down to the blood-rich layers of the dermis and the fatty hypodermis below. You've seen how it regulates temperature, fights off infections, grows hair, and heals itself step by step. So I want to leave you with this final provocative thought. Knowing how intricately it heals, protects, and breathes, how will you protect the armor that protects you every single day? Thank you so much for joining me on this incredible journey through the integumentary system. See you on the next explainer.